Hello, I'm Ben Humphrey from GameTutorials.com, and I'll be going through a quick tutorial on how to set up the rendering quality in Unity3D, as well as preparing your project for source control. In order to avoid terrible merge issues with other developers on your project, there's a way to set all your Unity files to be text instead of binary. That way, two people can commit changes to the same file without overriding the other's work. But first, let's start with going over the quality settings in Unity. Because this can make a big difference between your games looking like they are rendering on the original Xbox versus the cutting-edge Xbox One. Unity allows you to set the quality of your project by a few different levels in the Quality Settings panel under the Edit Project Quality menu option. By default, the project is set to the Good level. Let's go through the different quality levels and see some of the major changes that happen between each level so you can get an idea of the acceptable level of quality for your game. The Quality Settings panel has a matrix of quality options for the different publishing environments that you can build to. If we mouse over the icons on each column, you'll see a caption for Web, which uses the Unity3D plugin for the browser, Standalone, meaning a regular desktop computer game, iPhone, Android, BlackBerry, Windows Store apps, and WP8, which stands for Windows Phone 8. There are, of course, more publishing platforms like Xbox, PlayStation, Wii, and Flash, but those are not given in a standard download of Unity. Notice that the Good level is set by default. The green checks specify which level for the different platforms. Naturally, the mobile platforms have a lower quality level set by default than the desktop options, except for the Windows Phone. Let's drop it down to the lowest level by clicking on the fastest option. The most obvious visual change here is the texture resolution looks terrible and the dynamic lighting isn't visible. Notice in the rendering settings below, the texture quality went from full res to half res. The anisotropic textures and shadows were also disabled. In this room, there isn't much for real-time shadows since the objects are all static and it's using pre-rendered light maps. But if you had a character walking around, you would see a greater difference. With a character, you would also see the difference in animation since the blend weights went from 2 bones to 1 bone. That means each vertex or 3D point on a model can be affected by 1 bone at a time. You could see a big difference in the way the skin moves around during an animation. The pixel light count went from 2 to 0, which means that per pixel lighting is essentially turned off, which explains why the room became much darker. If you move to the fast level, you can see that our texture resolution goes back to full res, and our blend weights is returned to 2 bones. We also get an extra particle raycast budget for lighting. If we switch to simple, hard shadows are turned on, as well as anisotropic textures, which improve the quality of your textures when looking at them at skewed angles like the floor. Shadows add a big performance drop to your game, so be careful with how and when you use them. Going to Good gets us back to the default, which has softer shadows and VSync, which removes tearing. It also turns the light back on because the pixel light count is now 2. The second biggest improvement on quality besides the texture resolutions, Anti-Aliasing, which is turned on when you go to my favorite setting, Beautiful. This cleans up the jagged edges on your objects. Anisotropic textures are now turned to forced on, which makes sure all the textures in the scene use this filter. This is a huge difference. Notice how blurry the bed and other areas of the scene are without it. You also get 4 bones for the blend weights, which doubles the smoothness in your character animations. There's also a bump from 2 to 3 pixel light count, which smooths out the dynamic lighting. And finally, the fantastic level certainly is fantastic. Our lighting, shadows, and raycasts are considerably better. This truly is the AAA setting, but can kill your frame rate if you aren't on a top-of-the-line machine. I like to turn my anti-aliasing up to 4 or 8 on Fantastic because it completely smooths out any jagged lines. Let's turn on the bloom effect on our camera, which gives that AAA lighting look where it blurs the hotspots in the scene. This is usually more appropriate outside, but since we have some light shining right into the room, it works. I'll go over how to add effects like these in the later tutorial. Let's press play and take a look at our fantastic quality. Finally, let's quickly look at how to set up your project so you can play nicely with other developers with source control. Go to Edit, Project Settings, Editor from the menu, and you will see the Asset Serialization option. By default, it's set to Mixed, which means that your Unity3D files can be stored as binary and text. Having binary files makes it virtually impossible to merge changes in your scene and prefab files with other developers. Unless you lock the file, which makes working in a scene terribly inconvenient, you end up having other people overwrite your changes when you check in your changes to source control like svn, git, or perforce. To get around this, you can force the Unity3D files to text mode. That way you can merge changes if someone happened to work on the same scene or prefab file, which will happen all the time on a project. You can do this by changing the mixed to forced text. Be sure to do this at the very beginning of a project before you start adding files. This completes the tutorial on Unity3D quality settings and preparing your projects for source control. Stay tuned for our next tutorials, which get you started programming with Unity.